And then I want to share my screen. So 4A is what we're dealing with tonight. And 4A deals with formulas and examples. All right, so the first formula I'm going to talk about is what we call a simple interest formula. So simple interest is the most basic interest they can charge you. And simple interest is interest that they apply once a year to your account. So let's look at the formula for that. That's going to be A equals P times parentheses 1 plus the APR times the amount of years, or Y. So let me tell you what these letters mean. A stands for the amount in the account. P stands for the principal. So principal, or it's what you call the starting amount. So if I was wanting to invest $5,000, $5,000 would be my principal for that, okay? APR is the annual percentage rate. Now, when you use the annual percentage rate in this formula, it's got to be in decimal form. So they're going to give it to me in percent. We're going to convert that into decimal when we put it into our formula, okay? And then Y stands for the number of years. How long are you making that investment for, okay? I'm going to show you an example working the simple interest. All right, y'all, let me let one in real quick. All right, so we're starting to get a full class. All right, so this first example. We invest $2,000. So $2,000 is invested in an account that pays simple interest. Of 7% for 20 years. So they want to know how much money will we have after 20 years. Well, what we got to do is figure out what's going where in our little formula. So we're looking for A, which is the amount after 20 years. So we come down and we put our A. That's going to equal my P, which is my principal. So my starting amount, P, is going to be that $2,000 because that's my starting amount. So I'll bring down my 2,000. That's going to get multiplied by my parentheses. Well, inside the parentheses, we got 1 plus my APR. But y'all remember, APR was 7%. So we need to turn the 7% into a decimal. So remember, when you turn percents into decimals, you move the decimal left 2 places. So it's at the moment behind the 7. So we're going to move it once, add a 0, and move it again. So 7% is going to give me a 0.07. So we put that in for our APR now. So 0.07 times Y, which was right here. Y was 20 years. So I'll just punch this in my calculator. Most of y'all are going to knock this out in your calculator. But remember, if we worked it using order of operations, we would have to do inside the parentheses first. And inside the parentheses, you would have to multiply 0.07 times 20, get that answer, add that to the 1. And then once you got all that done, you multiply that by the 2000 would be your last step. But y'all, we got nice, wonderful technology. So I'm going to take the calculator and figure this out. So let me turn it on. So I got 2000 times, parentheses are above the 8 and the 9 here. So push the parenthesis, 1 plus 0.07 times 20, and then close your parentheses. So now we're just going to hit enter. And y'all, let me see, that looks like what, 4,800? So that was 4,800. So that means after 20 years, if I invested $2,000 in this account at 7% simple interest, I would have 4,800. So I basically would have made what, about 2,800 on that, okay? And that took me 20 years. So if you notice, simple interest don't pay a lot, okay? So y'all got questions on working that formula? If I'm not hearing anything. So next we will look at compound interest. Compound interest means this is interest that they tack onto your account more than once a year. So I'm going to show you some keywords on this one before I hit that formula, okay? Because they talk about what we call compounds. So the compounds can be annually, semi-annually, monthly, quarterly, and then they might hit you with daily. So let me just move this up just a little bit there. So if they compound annually, that is once a year. Which means if they compound annually and it's once a year, it's basically going to be simple interest. Semi-annually, that would be twice a year. So they're going to tack on interest twice a year on that account. Monthly, 12 times a year. Quarterly would be what, 4 times a year. And y'all, finally, daily. Daily means they're hitting interest 365 times a year. Okay, so I'll let y'all write that down, and then we'll turn this over and start looking at the compound interest formula. And just watch out for these keywords when we're working it, okay? All right, so here we go, the compound.
Professor Rentham, can you turn the paper back over for just a second?
Okay. Let me pull that back up for you. And let y'all get that bottom. There you go. It's different for me because my screen on this little laptop is a lot smaller than the screen was on my home computer. But the Homan didn't want to cooperate.
Okay, I'm finished.
You good? All righty. All right, y'all. So this is going to be the compound interest formula. And it's really similar to the other one, although it looks a little more complicated. So it's going to be A equals P times parentheses 1 plus your APR divided by N, close parentheses, and this is raised to the exponent N times Y. So A is still the amount in the account. P is still the principal. APR is still the annual percentage rate, but look, we got a new one. We got the N now. N stands for the number of compounds per year. So that's going to be coming back to that annually, semi-annually, and all that fun stuff. So notice the N is also right there. So whatever number we put on the bottom of this fraction, we put up here for the first part of that exponent. And then Y is still the number of years. And then, like I said, APR was still the annual percentage rate. So similar, except for now we're dividing by the N and using the N up here as an exponent, okay? Since they're compounding, you take the whole annual interest from the year and divide that by N, and that tells you what's happening each one of these periods they're hitting you with. So y'all, let me find my example on that one.
Why was annually included in that grouping of compounds if it's actually simple?
Because what happens when you put the 1 here, you just get the APR. And then if you put the 1 here, it just ends up being the number of years. So those basically become that simple interest formula. But they just like y'all to see how that sort of happens out of that. But yeah.
Okay.
Yeah, if I'm getting hit with interest just once a year, I'm just going to use that simple interest formula because it's quicker. But they derive that simple interest formula out of this formula, basically, okay? When they put the 1s in, they seen that those things were disappearing. So y'all, here you go. This one, we're going to invest $5,000 at a bank that pays APR of 3% and compound the interest monthly. How much will we have after 5 years? So y'all, let's figure out what we're about to put into this formula. We know A is what we're looking for. So A will be the amount we'll have after, what do we say, 5 years. So we put in for our principal. So remember, principal was that starting amount of 5,000. So I'm gonna put in that 5,000 times my parentheses. In my parentheses, I got 1 plus APR divided by N. So remember, they're giving me the APR 3%. We need to turn that into a decimal. So y'all move that decimal left twice. I'm gonna have to add a 0. So that looks like I'm going to get a 0.03. I'm going to put that in where the APR was. 0.03 divided by N. So y'all, since this is monthly, what is my N? So someone's saying a 12, right? Because I got 12 months in a year, so that's how they're figuring that out. Now, the exponent is the N again, which is going to be the 12 times the number of years. So we said that would be 5 years. So notice what's happening. Simple interest got hit once a year. So if you did that for 5 years, they would tack that interest on 5 times. 12 times 5, that's 60. So this account's going to get hit with the interest 60 times. So that should make me a little more money. All right, y'all, so let me show y'all this on that calculator. Now, by hand, you would have to figure out what's inside these parentheses. Raise that to that exponent, and then once you got that answer, multiply that by 5,000 as your last step. So the calculator can do all that. So let's punch in the 5,000 times parentheses, which is above the 8, 1 plus 0.03 divided by the 12. Close those parentheses. Now to make these exponents on the calculator, over here under the clear button, you got a little arrow. That arrow means you're about to put in an exponent. So you would hit in and then put in 12 times 5. So y'all, let me explain one thing on this. If you got an older TI-84 or a TI-83, when you hit that little arrow up, it's going to give you a exponent, but on yours, you need to put the exponent in parentheses. So you would put the 12 times 5 in parentheses and then close the parentheses. Because the older calculators don't kick it up into the exponent like these did, okay? So older calculators, you got to put your exponent in parentheses. All right, y'all, so let's see how much money we made in 5 years if we invested $5,000 at 3% interest. So I'm going to round this to the nearest cents. So it looks like I got $5,808, and let's see, I'm going to go to the 0.08. Since that's a 3, I'm going to keep that a 0.08. So just having $5,000 sitting in the bank for 5 years at 3% interest, you still made $808 on that, okay?
Are all banks like that?
Oh, it depends on a lot of times on loans, they go by what the Federal Reserve has set as the interest rates. So they're gonna vary depending on the interest rates of the reserves. But you really want more compounds when you're doing them, okay? So that's,
Is this in the real world context? Is this like savings accounts?
yeah, this is like investing in, oh,
Not
y'all-
checking.
Yeah,
Okay.
just if you had a savings account and you could put money back in to save money, maybe for a house payment one day, for a down payment, or maybe you got a college fund for your kids. So you can put that money in the bank and just let it draw interest over the years. So 3%, you're not making a whole lot of money, but you're making money. Whoops. All right, next we're going to look at what we call annual percentage yield. So let me write that. Annual percentage yield. And this basically shows you what interest you're really making on your money because of all these compounds. It shows you how you make more money by compounds when you look at this formula. So for the annual percentage yield, that's the annual percentage by which a balance increases in 1 year. So it's the annual percentage that an account actually increases. Whoops, I wrote my word wrong. Annual percentage that an account actually increases in 1 year. So to determine this, we can use any arbitrary, how do you spell it? Arbitrary amount to begin. So to figure out your APY, that's going to equal the absolute change divided by the principal. So y'all guess what? How do we figure out the absolute change? The absolute change is equal to the ending balance minus the principal, all divided by the principal. So the ending balance. So this, let's say I had $5,000 I invested for that year. At the end of the year, my account was 5,500. So the absolute change would be that 5,500 minus the 5,000 I started with, which would give me my 500, and then divide that by the principal to get that percent.
We got principal spelled wrong.
P-R-I-N-C-I-P-L-E. How do y'all spell it?
Isn't it AL when it's in terms of money?
Oh, so here's how I was taught on that. Principal with money would be like LE. Principal with an AL is like your high school principal because he's your pal.
Oh, okay.
Y'all ever heard that?
No, but that makes sense.
Yeah, they taught me that one year and I was like, oh, okay. All right, so here's an example using our.
Wait, Professor Random, can you turn it over just one more second? I'm almost finished.
I forget, I'm just yakking and talking and y'all are trying to copy all this.
I just looked it up on the internet and it's AL.
AL? Oh, okay. So I've been doing this wrong for a while now. So math people ain't very necessarily English people, right? Well, that's sad. Okay, so if I make videos on YouTube, they're going to think I'm dumb doing that LE stuff. Oh well. All right, so here's an example of annual percentage yield and how you can see you're really making more interest, or if you're taking out loans, paying more interest. So the bank offers APR of 2.29%. Let me pull that down a little bit. 2.29% compounded quarterly. Calculate the annual percentage yield, APY, for the year. So we just want to find that APY for the year. So remember, the APY is going to equal my absolute change over my principal. So I'm going to change that to an AL. All right, so what we got to figure out is that absolute change. So remember, the absolute change was my ending balance for the year minus my principal. So I'm going to assume I invested 1,000. Now, y'all, it don't matter what amount you use for the year. You can use 100, 1,000, 10,000. It'll still come out to the same percentages. So to me, 1,000 is an easy amount to use, but you can pick 500, any amount, okay? So what we got to do is figure out the compound interest, the amount that that's going to make in 1 year. Oh, drop my page. All righty. So here we want the ending amount. So the A ending amount is going to equal my P, which is my principal. So I just said I'm going to use 1,000 times my parentheses, 1 plus my APR, which is 2.29%. Remember, we need to turn that into a decimal, so we're going to move that decimal left twice. And y'all, that's going to give me a 0.0229. That's going to be my APR for the year. N on the bottom, remember, N on the formula was the number of compounds. We said this one was quarterly. Quarterly would be 4 times a year. And then the exponent would be 4 times the number of years. And we're just doing this for 1 year because we just want to see what the yield is per year. All right, so I'm going to bring the calculator back and let it do this part. So y'all, I'm going to punch in my 1,000 times parentheses 1 plus 0.0229 divided by 4. Close your parentheses, hit the arrow up key, and then that was 4 times 1. Remember, old calculators, when you hit the arrow up key, put that 4 times 1 in parentheses. All right, y'all, so let's see what we're getting. So I'm gonna round to the nearest dollar or cents. So that's gonna be what, 1,023 point. So that's a 09, behind it's a 7. So that 7's going to turn the 9 to a 0, which carries over. So the 0.097 is now a 0.10. So at the end of the year, that account had $1,023 in it and 10 cents. So let's get the absolute change now. Absolute change is going to equal the ending amount, which is 1,023.10 minus my principal, which I started with, was 1,000. So the 1,023.10 minus the 1,000 is going to give me the 23.10 left, okay? So y'all, let me explain what we got. So $23.10 is how much that account made in interest. That's the change that it had, okay? So now we got our absolute change. We know the principal. Now we can find that APY. That's going to equal my $23.10 divided by my starting amount, which was 1,000. So let's divide that and see what we get. We got 23.10 divided by 1,000. Whoops. 23.10 divided by 1,000 is going to give me a decimal 0.0231. So y'all, now that's in decimal form. Remember, they're looking for the APY percent. So we got to turn this decimal back into percent by moving it right 2 spaces. So that gives me 2.31. And then I add my percent. But look what happened. Since it got compounded more than once, the actual interest you made was 2.31% versus the 2.29%. So that's how them compoundings can either give you more money in an account or give your loan people more money in their account, okay? So it's not too bad. You just got to keep up with formulas doing this. But you would make more money. What's that? That's almost a whole 10th higher. Close. So 3%, not as much. If this thing was up there 5 or 6%, then you'd see a little bit more money being made. Okay, so this next formula, let me hold that paper down. This next formula, suppose you had children and you wanted to save for them to go to college. And when your kids were graduating, they'll be what, 18? So by the time your kids were 18, you wanted to have $50,000 in the bank. So you found you a bank with a specific interest and compounding. And this formula would tell me how much I would have to start with. What would my principal need to be in the beginning in order to have that 50,000, 100,000, or whatever I needed after a specific time of years, okay? So this is what we call finding the principal and you know what's sad? My actual problems, they spell principal with an AL. And I just ain't never noticed that. All right, y'all, to find the principal, that formula would be P equals A divided by parentheses 1 plus APR divided by N, all raised to the N times Y. So basically what they did to get the P, they took that formula we had a while ago and divided the A by what the P was being multiplied by earlier. So same formula, they just rearranged it to get the P by itself. So this is going to find the starting amount you need to get that college fund. So everything means the same. P is the principal, A is the amount in the account you want, APR, annual percentage rate, must be a decimal, N's the number of compoundings they're giving me, which you're going to put in both places, and then Y is the number of years. So let me find, I had a good one for that.
Maybe the internet's wrong.
On the principal?
Maybe.
Oh, I don't know.
It's LE.
Huh? You seeing LE now?
Yes.
Yeah, so who knows, y'all? That's a question of the day. All righty, so this, we're going to find what we need to invest to get our money. So what I want to do, I want $30,000 for a down payment on a house. I found a bank that would offer, so the bank offers 4% interest compounded monthly. How much do we need to invest? So this is about to tell me if I did want to invest money to have $30,000 after my, oh, let me see, how long did I do this one? Oh, this is 5 years. So I got 5 years. So we have 5 years. So we're going to invest. We got 5 years to make our money. Let's see how much we need down. So our formula was P, which is going to be the principal I need to have down, equals my A. So A, I wanted $30,000. We're going to divide that by parentheses 1 plus my APR. So what was my interest? 4%. We're going to turn that into a decimal, move it left twice. So I got to add me a 0. So that's going to give me a 0.04. So 0.04. Let's see, we're compounded monthly. So that'll be 12 times. And then my exponent's going to be 12 times the number of years we said was 5. And y'all, the calculator's nice at doing them problems too. So let me get this where y'all can see my screen. So I'm just going to put in the 30,000 divided by the parentheses 1 plus 0.04 divided by the 12. Close your parentheses. Remember, hit the little arrow up for the exponent, and that's going to be 12 times 5. So y'all, I'm going to hit enter, and that's going to be the starting amount, and I'm going to round that to the nearest cent. So it looks like I'm getting $24,570. And what's that, a 0.093? So I'm going to leave that at a 0.09. So that tells me if I wanted to have $30,000 in 5 years at the interest rate that bank's giving me, I would have to start out with $24,570. So if you already had money saved, put that into that bank, let it sit there for 5 years, and then you'll have your 30,000, okay? So that's the kind of stuff people do to try to plan that out, right?
I
No,
got a
I
question.
So did I hear a question?
Yes, sir.
Yeah.
So is 12 equals the number of months per year?
Yeah.
Okay.
Mm-hmm. And you get that from right here where they say like compounded monthly. And then remember, they use words like quarterly, semi-annually, and stuff like that. All ready for me to turn? All right. So let me pull that back down a little. So another example doing the same thing, and this one was the one about the college fund. So how much must be how much must be deposited today in order to have $105,000 in 12 years for a college fund. So these people want to have a college fund. So they got 12 years to do it. They found a bank with quarterly compounding. At 7.66% APR. So they got a little better interest rate than my other one done, and I think they roll them interest rates based on your credit scores and all that fun stuff. What's the Federal Reserve doing at the time? All righty, so we want to find how much we would have to put in the bank to have that 105,000. So remember, we're looking for the principal again, which is our P. That's going to equal our A, which is 105,000. Divided by, remember my parentheses, 1 plus my APR. So we're going to have to convert that again. So move the decimal left twice. So it looks like we're adding a 0. So we're going to get a 0.0766. So 0.0766 divided by N. So y'all, what is my N if I got quarterly compounding?
Four.
4 times a year. There you go. So then that's going to be what, a 4 times the number of years, which was 12. All right, so I'm sort of interested to see how much money they actually gotta have in the beginning to get this. So y'all, here we go. We got a 105,000 divided by my parentheses, 1 plus 0.0766 divided by the 4, close parentheses, arrow up, 4 times 12. So when I did that, y'all look, we got what, 42,243 dollars, and so that's 5.1. I got a 7 after my 1, so I'm gonna make that a 2. So that's gonna be 0.52. So they made quite a bit of money on that. Let's see what they made actually. So 105,000 minus $42,243.52. So look at that. They made $62,756 off of that account by just starting with 42,000. So if you got money to invest and you want to save for college, find your banks that pay good interest, and hopefully you got enough years to make it grow real good for you. All right, so that was an example of the 4 formulas I wanted to show you. So the homework will have questions sort of asking you to compare simple interest and compound. And then most of it's just going to be finding those amounts. All right, let's see. Yeah, so let me explain what I want y'all to do with my activity. So y'all should have got an email with some files on it, and I'm going to pull that file up real quick. So let me try to stop that share. I'm going to go share the screen with my Excel file. So y'all, I sent y'all this file the other day. Oh, I can't remember if it was last night or the day before. And I put all the data in for this family. Now, at the moment, you notice if you go down to the bottom right where it says net monthly cash flow, they're in the red, $260.45. So they're negative. What I want y'all to do is go through here and figure out places where you can eliminate some of their debt and get them into a net monthly cash flow that's in the black or positive. Now, some of these you're not going to be able to change. The home mortgage, that's going to be $1,349 no matter what. You can't really change none of his taxes. But go down through these and see if there is places where you can save them money that they might not need to do, okay? So if you don't think they need to do entertainment for 65, take that away. Health club dues, groceries, maybe they don't need a cell phone, stuff like that, okay? Try to eliminate some of their debt so that that becomes a positive monthly cash flow. So all you would do is just click in here. So they probably need their internet and their gas. So let's see, not much you're going to change there. Oh, they might not need cable. So you could go into the cable and put a 0 for that amount. And notice what that did. That brought my monthly cash flow from the 200s down into the 194 range. Okay. So just go through there, change amounts, and make that end up being positive. So this ain't gonna be a hard project. I just wanted y'all to get used to being on Excel, okay? So some of y'all probably had Excel experience and some of y'all didn't. So this is just getting y'all ready to use Excel, okay? All right, let me get my time check. So y'all, let me ask y'all, do y'all have any questions on this 4 formulas?
I came in late today and I was just trying to see, did you have any formulas before? Let's see.
I think I caught you in the beginning when you came in. So let me share my first page I did and see if it looks what you had. So I'm gonna share my camera real quick. So Shanita, my first page looked like this.
Okay, so I got it all. Thanks.
Yeah, I think you came in pretty much when I was just barely starting on it. All right, so y'all remember, test 1. If you're not happy with your first score on test 1, it's set to be retaken, but you got to have it done by Friday at midnight. So if you want a higher score, it'll keep whatever score was higher in the grade book. Remember, you can do that again if you want to. So we will pick up in some more of chapter 4 next week, and I will start breaking out information for your first project. So I'll be sending y'all a file for that. Probably over the weekend you'll get it, okay? It'll be a file, and it's called Financing My Car. So this project you're going to go through, you're going to look at different loan offers like Wells Fargo and different loaning companies. Find you a loan for your car and all that fun stuff. So you're going to get to pick your dream car and see how you're going to get it financed and stuff, okay? So y'all be thinking of a car you want to buy for next week. All righty, y'all, any questions? All right, so I'll stop this recording and I will send this out later after I upload it